Forget to put your camera on, don't be shy, and share your face with the light. Fantastic advices from Dr. Elena to start our second meeting in Agriphotonics. I'm super excited today. It is a few days after Photonics Plus. Many of you joined Photonics Plus. It was a fantastic trial to make something online, but today we are here to do business. So I expect each and one of you to generate a lead. And in the next 2 hours, Elena and me are gonna work like crazy to make that happening. Welcome to the second meeting on Agriphotonics. February 22nd, 1 week after we gave roses to our beloved ones on Valentine's Day, our online technology meeting will revisit the topic that generated the most positive feedback so far, Agriphotonics. Back in July, we were the first to visit a medical marijuana farm at SILIOS for a live discussion on the state-of-the-art photonics they use. Yes, it really happened. You can find it in YouTube and everything is legal. We also brought together John Deere, Lima Grain, and Yes Health with new approaches in lighting and sensing on the farms of the future. The main takeaways were the reduction of water and energy and the trend towards hydroponic systems, that is horticulture without soil. We also studied how to apply UV light directly at the root of the plant. We challenged the supply chain with the accurate real-time measurement of ammonia, nitrogen, phosphate, and potassium using handheld as well as drone and HAP-based spectroscopy. You don't know what a HAP is? This is a HAP. Here comes a unique offer. The company smartHAPS has positioned itself at EPIC to provide a platform for testing any camera or sensor for agriculture or environmental monitoring. What a great opportunity, especially this year. That's why on Monday, February 22nd, we'll combine a reunion with brand new invited guests such as Tomra, PepsiCo, BASF, or SeeTree. And what about EPIC member Osram? Plants are very selective on the color of the light that makes them grow. It's all about wavelength tuning and accuracy. 2 absorption peak wavelengths, red at 660 nanometers and violet at 450 nanometers, have become the light fertilizer. But each plant is a universe, so the farmer's secret is in customizing light or building a dynamic lighting recipe for each plant. So here comes the EPIC Photonics community with their hyperspectral and multispectral sensors. They are able to measure the chemical composition of the plant, its water and its air with the highest accuracy. And I'm thinking of EPIC members including HiSpecs, Xenorics, SPECIM, Xenix, MantiSpectra, Ocean Optics, Living Optics or HORIBA. So switch on your lights, water your plants, and be ready to join us on Monday the 22nd of February at exactly 3 p.m. because Agriphotonics has arrived. Indeed, Agriphotonics has arrived and we are super excited for the supply chain that we are building on that sector. First of all, I would like to tell all of you that EPIC keeps going, that we keep growing. We are almost at the 700 line. I think it's 690-ish already. And as soon as we make a 700, we'll make a party with all of you. I would like to say it, of course, as every meeting, I am here talking on behalf of a fantastic group of people who dedicate their life to the photonic industry, 15 people, half of them with PhDs. And what we do for our life is basically first, we make fantastic events. We connect the companies. We introduce companies constantly. We help companies raising capital and we never get a cent out of that. Our business to make sure that you do business. We have the biggest website to get a job in photonics, jobsinphotonics.com. And as usual, we give you free market data for all the members. Getting fantastic market reports is part of your membership benefits. Today, we are already well through the third season of EPIC Online Technology Meetings. And today we are dealing with Agriphotonics, but mark your calendars for the meeting next Monday. We are dealing with green energy. We're going to talk about the hydrogen fuel cells. We're going to talk about the solar cells, and we're also talking about the wind turbines and what photonics can do in those particular market segments. I'm very excited about this because, as you hear from a lot in EPIC, 2021 is the green year for EPIC. I also would like to remind all of you that EPIC organizes now also quantum technology meetings. For those of you who either are very active in quantum technologies, or because you don't know what it is, but you hear that there is a lot of money there and you want to see the business of your technology, mark your calendars for the upcoming meetings. On Friday, 26th of February, we are talking with the security and defense sector. And I would like to clarify, obviously, for this market segment, that meeting will not be in YouTube, the participant list will not be shared, and the only way to get a contact with that industry will be to attend the Zoom room. And if you want to attend that meeting, please contact me by email only. But also today, Agriphotonics. I would like to first of all acknowledge the support, the amazing support we are getting from our media partners, Electro Optics and AZO Optics. You're making such a huge push for making sure that what you are doing here at EPIC is known worldwide. Thank you so much. And also, this meeting would not be possible without the support of our fantastic sponsor today, Chroma. Chroma is one of the best suppliers in coatings and filters. You're looking for optical filters for any wavelength range. Some of the best filters in this industry, you can find them from Chroma. Thank you so much for being a sponsor today. And a fantastic agenda and all the acknowledgement and appreciation for the EPIC expert on life science in our staff, Dr. Elena Beletkaya. Congratulations on the fantastic job that you're doing. What's in the menu today?
Thank you very much, Jose. Well, today we have quite a number of interesting talks. We will be talking about different sensors, cameras, how we can actually implement them, what challenges do they help to overcome, and how we also can test them. But more importantly, we actually have a full supply chain here. A lot of companies from lasers, filters, optics, photonic integrated circuits, sensors, obviously system integrators, end users, they're all looking for the ways of how make the precision farming even more precise, even better, how to help the society, how to reduce the waste. We also have artificial intelligence to help it out. Of course, a lot of R&D and testing hubs over here. So I think that we should just move on and see what this community has to offer.
Great job, Elena. This slide only represents the companies who registered for this meeting. So you're an EPIC member and you miss your logo here. That only means that you forgot to register. Don't make that happen again. If an event is relevant to you, register online. Don't wait for an invitation from EPIC. You're an EPIC member and everything we do is always for you. I would like to remind everyone that this meeting is also live streaming in YouTube. So hello, YouTubers of the world. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.poto@epic-azoc.com, and I will be more than happy to make the introduction. Of course, if you have any question, please post it in the chat and I will read it in the Zoom room. This, of course, also valid for the people in the Zoom room. This meeting is, of course, has our internal private chat. Use it constantly to get in touch with each other and discuss during the presentation. This is about doing business. Of course, after the meeting, if you want to get in touch with any of the participants, you didn't have a chance to talk with them, send me an email and we'll make the introduction. As Elena very well said, time to get started. And we wanted to start with something really, really amazing. There is a company that actually wants to make a network of smart trees to go towards the optimization of farms. And photonics plays a role on that. So I can't be more excited for this. I want to start with the company SeeTree and understand a bit what photonics can do to enable one of the most amazing dreams in the history of agriphotonics. Thank you very much, Gideon Alon, Head of Sensing Technologies at SeeTree. How can we help you? The floor and the attention of everyone goes to you.
Thank you very much. I will share my screen. I hope you can see it.
Crystal clear.
Excellent. Thank you very much. Well, first of all, I hope I will sound as exciting as you, Jose. That was an excellent introduction. I really hope that I will catch the attention of everyone like you did. My name is Gideon Alon. I'm with SeeTree, and I'm very happy to be here with you and to discuss with you a little bit about what we do at SeeTree. So I wanted to give a little bit of a context as to where we are right now. I'm sure people have it in the back of their brains, but you know, the first generation of farming is what we went from gatherers to farmers. Okay, that was the first generation. Second generation came where we really increased the yield. Okay, The third generation obviously was the industrial machinery revolution. And then where we are right now, we're in the generation number 4. Okay, this is how we look at things. And we are obviously in the generation of big data, and we are bringing this into the agricultural world. And this is how we're looking at things at SeeTree. So what is it that we actually do? Well, as I mentioned, we're building actually a per tree big data network for many, many millions of trees worldwide and over time. Okay, if you can think of it as your health file per tree over time that you can go back to and have inferences into the history and possibly into the future of what may happen and what kind of decisions that will allow you to take. We help increase yield by tracking the health, detect diseases, pests, and also tracking the food productions. And we the boost the ROI, both of the industry and of the users, by leveraging this digital transformed agronomy, the operations and decision-making. So as you may imagine, obviously we have some input data pipeline. We use multi-layered data collection and analysis campaign at different frequencies per data layer. And we have a very high resolution RGB and multispectral data that we leverage to give our services. And I did mention in the first sentence that we are a service providing company, okay, which is a very important distinction to make. So very briefly, going through the main concepts of the pipeline, we have a collection flow that utilizes several multispectral bands. We also have very high resolution RGB, as I mentioned. We also have ground operation. We merge those and synthesize all of these into an analysis black box, if you will, or not that black, that allows us to classify the health of each individual tree, to index it per tree over time. Every time we come back to the same tree, it has an identification number, if you will. We have inferences on the geometry of each individual tree, and we also look at the fruit estimates. And obviously, out of that, we can generate a lot of information and a lot of plots and so forth to the customers. However, I think something very visual to look at would be at this slide that gives you real actionable information, okay? This is a spatial distribution of different parameters that are actionable to our customers. So at the left, we give scores as to the health of each tree. We can also give scores as to the state of the pests. And these are not always the same colors and distributions. We also give inferences into the spacings of the grove within the trees. It's very important for operations in the farm to take the right decisions of how to operate machinery within those groves, okay? And we also give geometry analytics of the distributions of what is going on in each individual grove. This is very important because usually farmers would like to not have variations, would like to do very efficient farming. If they do have variations, this is something they would like to look at. As I mentioned, the tree health is distributed over a range that we have developed for our company, from the left side, which is great, to the right side, which does not exist. Number 1 is obviously dead. And we also look at regrowth, which is also very important. And we present it, whether it's mobile or whether it's a web application, to the decision makers of the farm very intuitively, so they can really disperse their resources effectively into the places that they need to at most. Okay, now we don't only stop there. We, as you can imagine, go down into the grove level, and we can really see where things are happening at the grove level. In this case, this is health. We can really show statistics from the ground up and really prove that our data is coming from something that is really based in reality at the very fine level. As you can imagine, we also go down to the tree level and really score each individual one. And of course, we can prove at the very high resolution each individual tree and really prove why we scored that tree as a 1 or we scored that tree as a 5. It's not something that is averaged over a big number of trees. This is per tree evaluation down to the details of whether it is a pest, whether you have weeds on the side that prevent you from working efficiently between the rows. Everything is there. Farming efficiency, something that was mentioned in this conference. We can detect problems, for this case, for example, in water irrigation, that we can help the farmers to fix and improve, and then their efficiency obviously grows. We can also help detect early problems within the groves, whether it is with multispectral data on the right side of a certain bug, if you will, and on the left side you have an issue with a fungus that we have detected. I think this is a good slide because it gives an idea of what we deal with. We are a global company that operates on many continents and it's expanding. We're also looking at citrus, of course, as you may have seen, but also over other crops. Over 50,000 hectares, over 30 and increasing million number of trees, and a lot of data per day. And then last slide, as I mentioned previously, we are a user and we are integrating sensors to make this happen. And if I quote from the meeting, we're talking about quality monitoring. This is exactly what we're doing. We are monitoring farms which are not field-based farms. This is permanent crops that we're monitoring. And in terms of farming processes, these are exactly the types of data that will allow the new generation number 4 farming processes that we're trying to leverage. And the last thing I would like to say as a sensor integrator and a user, we really think about scale all the time. So there are a lot of excellent new sensors out there. They can be LiDARs on a chip. They can be quantum LiDARs, excellent ideas and things that are coming into, but every time we implement it, we have to think about giving service to 50 million trees or so. It's not a local project. So we need very high spatial resolution in all bands because this is what we do. We have to have it go on drones at least. So in terms of swap and see, we have to have miniaturization, we have to make it durable, and we would like to see synchronized multi-sensor platforms, which are obviously things that people are aware of, but when we think about scale, all these things come in together, and we have to make sure that they really flawlessly execute in order for us to serve 50 million and growing to hopefully towards 1 billion at some point. This is what I had to discuss with you. I had a couple minutes to take some questions, if you will. Thank you, and would love to hear the next lectures.
Thank you so very much, Gideon. That's such a great introduction to our meeting, and we start right away with such a great sensor wish list, and we have quite a few companies which are making sensors. So let's see if we can directly help you out here. So I know we have Hamamatsu in the room. So would you like to comment on the sensors wish list, and is that something that you could be helping out with?
Yeah, so thanks for that. Yeah, so basically it's brilliant to see someone with a wish list. It's exactly what we want, certainly at Hamamatsu. And you know, with things like that, it's really good. Some miniaturization was something that you mentioned, and that's something that Hamamatsu are really, really pushing forward in, especially with spectral sensors such as spectrometers. So that's something that I think I might try and reach out to you afterwards and discuss. But I think, yeah, it all sounds really quite, it sounds doable, and it's always good to have a wish list, like I say. So, you know, durable, small size, and good spatial resolution seems like something that's, that really the industry itself is moving towards, I think, is trying to provide that.
Okay, great. Thank you, Kevin. We also have some questions in the room, obviously, as expected. As expected, we have a question from Jan from Kylester. Jan, what's on your mind? Share with us.
Gideon, when I saw your examples, I have the impression that most of the features you like to detect are below the resolution of a pixel or a ground sampling distance. So what is most important to you, either increasing resolution or increasing sensitivity?
Well, resolution, of course, is a big part of what we do, as I mentioned. As we move on to larger and larger farms, we need to maintain the ability to serve large areas. And if you bring up your altitude a little bit, you lose your resolution quite quickly. The sensitivity, as you mentioned, currently, I think the sensitivity is probably not the limiting factor in our case. We're exploring to add additional sensors into our platforms and systems. But I would say that probably resolution, because that would allow us to probably push higher our altitudes and then serve larger data more efficiently, more effectively in maintaining the GSD. I'll go with that.
Okay.
Great, thank you. And we also have questions coming out of our YouTube universe.
No, they're coming out of your Jose universe. Very, very good, Gideon. Amazing presentation, full of opportunities for our members, full of opportunities. But I want to really make something very clear. So we want to bring sensors, and we have fantastic sensors. You're going to hear from MantiSpectra, from Ipsen, from Xenorics. We have really great technologies for you. How do we test them in your platform? Is there a way to just is there a common interface? Is there a way to actually just bring the sensor to you? How does it work? How can we help you?
I think probably, contacting me and trying to test it out, that would be the easiest thing to do. We're not a big corporation. We're a startup, as you mentioned. So if you want to make things happen, we know how to make it happen pretty quickly. So we have knowledge of integrating various systems together. I think the best way is to just direct message, and we'll take it from there.
And it was very clear for you that the lifetime and reliability are key challenges. So you're going to hear from Wasatch, they make fantastic Raman sensors. Reliability and lifetime, do you have some specs, some dreams? What is the standard lifetime of a sensor in the SeeTree SmartTree structure?
It's a good question. We do not exist, 20 years. We're only a few years. So we essentially, as I mentioned, we took sensors that are out there on the market that we think are going to be reliable enough, but you always have issues. Even if you look at normal standard RGB cameras, if you click the shutter many times, and as you can imagine, you click them many times, something at some point will go wrong. If you can imagine, even at that level, it doesn't have to be that one pixel would not respond at certain wavelengths. It would happen sometimes on a mechanical level. So that even at that maybe naive point of view, that also can affect operations at scale. So as I mentioned, we always think of scale.
We have a question in the room from Wasatch. Dieter, what's on your mind?
Hi, Gideon. That was fantastic, and I was just wondering if you had your wish list in terms of wavelengths or spectral range. What wavelengths are important for you for like a spectral sensor or say a hyperspectral camera that can fly on a drone?
You are muted. We cannot hear.
Right. I was muted.
Here.
Right. So there are hyperspectral sensors out there that also go on drones, but since, as you saw, one of our pitches is to be able to really prove our case to the farmer by showing her or him an image of the tree with the problem. So if you look at the hyperspectral sensors out there, they don't have tens of millions of pixels, right? They have many less. Or even the multispectrals. The multispectrals are better. You have more options there. So, and since the entire pipeline takes all these sense data together into the pipeline, we would like to have resolution maintained. So going into sensors that have 2 or 3 megapixels as opposed to tens of megapixels, that would really alter the pipeline that we do. And this is something that would really help. And in terms of spectral, here it's maybe a little bit more not fishy, but a little more dicey, because it goes into the IP of which wavelengths you're using to detect a certain issue or certain problem. So we're looking into the entire range for now.
And now I go to YouTube and I get their questions. The first one was already answered. We have from the company Emberion, Samuel Hack. This is a company that makes amazing graphene detectors. And they are asking, do you use near infrared or short-wave infrared for your applications? I think you answered that really, really well. The second question is coming from the IIT in Genoa, amazing institute. In Genoa, they are wondering, do you have any instruments that also include an active light emitter, or are they only based on the receiver camera stage? That was Fabio Calegari.
Excellent question. We're looking at passive sensing for now. We don't have anything that is currently, in the emitting side of things.
And that's because of price. That's because of cost.
Also, but this is currently this is how we make things.
There's a lot of activities that we're going to do in the mid-infrared, and I want you to be one of the key companies in integrating our sensors in the mid-infrared, 3 to 12 micrometers for every chemical composition. Back to Elena Beletkaya.
Well, I think we're actually going back to our speakers. I'm very excited to hear the next presentation. It's from César Martínez, CEO at smartHAPS, and he will be telling us more on how we can be testing all the different technologies. César, we already see your presentation coming up. Let's put it in presentation mode. And just to play the presentation.
Okay.
Yeah.
Thanks for the opportunity. Thanks to Elena and Sarara, Jose, and all the EPIC team for the excellent work, as usual. So I'm going to show you another part of the chain. This is a platform. It was mentioned by Jose in the introduction. We provide a different source of data. I mean, different from the satellites and different from the drones, from in situ measurements. So the name of the company is smartHAPS. So the problem is, you already mentioned, agriculture need to improve, to increase the productivity with, let's say, traditional ways. But it was mentioned in the previous presentation, we are in the digital era, so we have to focus on this kind of improvements. So the opportunity is coming in Europe for the new European Common Political related with the agricultural, the CAP, Common Agricultural Policy, because the countries need to monitorize very large areas, even the 100% of the areas. So sometimes the resolution, not only spatial but spectral, or are not can be achieved by the satellites or by drones. So the idea is to use what we call HAPS. It stands for high altitude pseudo satellites or high altitude platforms. We are planning to use airships operating in the stratosphere, in the low stratosphere, something around 20 kilometers, because this altitude is good. It's good because the winds are very low at that level. And the idea is to keep the platform fixed in the air, covering an area of interest. The platform, I mean the vehicle, is powered by solar energy with some engines and some attitude control subsystem to keep the position. So this kind of platform has a lot of advantage with respect to the satellites. The first step is the sensor is closer than satellites. Instead of 700 kilometers, we are only at 20 kilometers. We have persistence, we have continuous coverage of the area. That is quite important. And the operation time is calculated something around 4 or 5 months. Just imagine that you are going to receive real-time data over an area for 4 or 5 months. And one of the important characteristics of these platforms is that they can be recovered for maintenance own upgrades. So the idea is we launch the platform, launch the vehicle, operate over an area. After this kind of operation, 4 or 5 months, we recover the platform, we perform maintenance, and we launch the platform again. When we are operating over an area, it's quite important to mention that we can move to other area because we have the capability to move with the engines to other area. So if we are covering a city, for example, if we need information from other city, we can move to the other area. So we think that it could be a powerful solution for agriculture, forestry, and land use surveillance. We can monitor areas typically 20 by 20 kilometers. It depends, of course, in the field of view of the sensor. And the idea here is we detect very small changes, and we can track highly dynamic processes. So regarding application, you are expert in agriculture, but we should meet the requirements of the Common Agricultural Policy in Europe. We can help precision agriculture and forestry. We can monitor fires in the forests, and there's a lot of application related with agriculture. So what we are looking here in an EPIC is collaboration, in particular with sensor developers for joint project. And also we can provide some of you the opportunity to qualify your instruments in flight with stratospheric balloons. And that's all for my part.
Qualifying the instruments with the stratospheric balloons. If you allow me to add, amazingly beautiful stratospheric balloons. I'm a huge fan, César. César, in the previous meetings, I already told you I want to position smartHAPS as the place for our EPIC members to validate their technology. We talked about hyperspectral cameras in the past. Is there a particular interest on hyperspectral cameras? Is there any challenge that you have there to bring the cameras? What could be this item in Santa Claus Christmas list for you?
We think that we are now validating with the final users the business model, and we detect a strong interest in the thermal spectrum. That's quite interesting. For some measures, it's true that there are already some detectors in satellites, hyperspectral, even multispectral, but there's a few of them in the thermal infrared. So we detect that interest.
Thermal imaging cameras from a far distance. So yes, beyond what companies like Fleet are providing. What kind of temperature are you measuring? Is the temperature of the ground, the temperature of the air around the ground?
The ground, some measure related with the water in the plants and so on. So that is good. We detect.
Well, let's start the business now. So let's go to Gideon, because I think there is obvious collaboration between the two of you. Gideon, what's on your mind?
Just a quick question. What's the planned distribution or coverage globally of these kinds of platforms?
In fact, it depends on the field of view of the sensor, but the idea is to cover as much surface as we can. The idea is we can move the platform, we can cover an area, move to a new area, trying to cover the 100% of the territory. So that's the idea. But the key point is that we can cover an area and then recover the platform, install a new instrument, a new sensor, and check the behavior, the evolution of everything in other wavelength, for example. So we think that's a powerful platform because they combine the advantage of the drones and satellites, and on the other hand, they avoid the problems of these kind of platforms.
So we're going to start a project here between SeeTree, smartHAPS, and a company called Xenix. I have Mark Larivey in the room. Mark, in previous discussions, we talked a lot about the need for SWIR cameras, the need for next generation cameras, reliability, price, small aspect ratio putting in drones. How does the addition of having a smart hubs, having hubs put in your cameras, how does it sound to you? What kind of cooperations arrive in your mind?
You hear me?
Loud and clear.
Yeah. Okay. So definitely, this is a good idea and a nice way to set up future collaboration, because I see that as something complementary, as a complement to the drone, especially because you cover something much wider. And my understanding is that you are not only interested in short wave, but also in long wave, in thermal band, where also you have plenty of applications. So that's definitely of interest for us, and we'll be very keen to keep in touch with you because definitely it's interesting.
We discuss with you very often about the high temperature thermal imaging part. So when it comes to more than 150 degrees centigrade, and I get that question, I always direct them to Xenix. That has been my go-to way. When we talk about the wavelength range between 900 to 1.7 micrometers, what kind of applications do you see for the monitoring of agriculture?
According to me, it's much more chemical way of monitoring. The thermal part will be for, let's say, temperature, or probably moisture also. But the short wave is moisture evaluation and chemical evaluation.
I would like to ask you something else. You have fantastic SWIR detectors and they cover a large wavelength range. Do you have any needs? Because I always want to find customers and suppliers. Do you have any needs for filters? Because I have very good filters in the room.
You mean at the camera level?
Yes.
Yeah, the filters is also a possibility to select the wavelength you want to focus on. And that's the point. We have the possibility to set up some filters due to set up the camera. So yes, definitely it could be.
Fantastic. So we start from the client, we go down. Let's go to find your filters. Is there anybody from Chroma in the room? Have anybody from Chroma? 1, 2, 3. Yes, I know she's there. She's trying to unmute herself.
Sorry, I had to unmute.
We are looking at the wavelength range that covers the near infrared and the short wave infrared. So we are trying to see where we can put cameras for both the measurement of thermal and chemical compositions. What is the interest that you're getting from your customers? Chroma makes fantastic filters, by the way. The interest that you're getting from your customers in this wavelength range for the agricultural sector.
You are asking
obviously
me? Yes.
Almut Bailey from Chroma Technology.
Yeah, so Chroma Technology makes all kinds of filters, mostly for the visible range, but we've extended our capacity to the infrared, near infrared, up to 3,000 microns. So whatever your bandwidth is and whatever your cone angle is, just let us know, and we can make these filters just matching to your request and to your specifications.
Since Chroma GmbH joined EPIC, you have interacted with many members, and I have to say I got fantastic feedback from the relations that you have created. So I think you have one of the best filters that we have in EPIC. I said the best many times, and I don't regret it. Thank you so much, Almut, for being here. We started the meeting, we got it rolling. Now we're going to talk about my personal passion, light recipes, and nothing better than Crocus Labs for taking this on board. Co-founder and CEO of Crocus Labs, Prashanth Makaram. Thank you very much for being with us this afternoon. Tell us about the right light recipes for growing crops, and especially how the companies in the lighting and in the sensor and colorimetry market can help you. The floor and the attention of everyone goes to Crocus Labs.
Thanks, Jose. But let me share my screen.
It's happening. Yes, go to presentation mode.
Cool.
And then you have to switch the screen that you're sharing with us.
Okay, cool.
And now we see it Gorilla Glass clear. We hear you clear. The floor is yours.
Cool. Thanks, Jose. Today I'm not going to touch so much about light recipe, but more on the light itself. So just to give you an idea, we are Crocus Labs. We are a very young company. I think probably the youngest company today here. We are, we registered in December. So we are a very, very early stage startup. So what do? We are based out of Berlin, Germany. We develop ultra high efficiency smart lighting solutions that combine not only the novel LEDs technology, but also sensor systems. So what we call ourselves as a Crocus Light platform. So we start with our tunable Crocus Lab LED solutions, and then on top of that, we have our own drivers and circuitry. And then here is where we look for partners, especially we integrate a whole array of sensors, and this is basically we offer Crocus Lab Light as a platform to our customers, and we have our own embedded algorithms in this. So this isn't just what Crocus Labs does. The challenge that we are addressing, at least, is that we see that in indoor farming, we made the greenhouses, vertical farms. The farms are really not profitable these days. Most of the farms that you see, at least 75% of the farms in vertical farms are not profitable, and this is really related to the huge OPEX costs rising from artificial lighting. So in green or indoor farms, it could be 25 to 35%, and some vertical farms we have spoken can be up to 80%. So what we the indoor farms, I think if they have to really take off, they have to solve the energy problem. If you look at today's market here on the right, you see some data from 2019 study, which shows that the companies that use high intense lighting inside, about only 86% of them use still the old sodium pressure lamps, and only 11% of them use LEDs. And there was also a theoretical study that showed that if we switch all the HPS lamps from that's out in the farms in the US now to LEDs, we will only save only 35% in electricity. That is not enough for farmers to switch. And so there is a big mandate for everybody to switch to LEDs. They want to do all the green things, but the incentive is not there yet. And the reason is that the current LEDs are quite limited in their efficiencies. And this is what we want to change. We want to first start with our diode technology changes, and later on to integrate sensors so that we can improve the performance by a magnitude. So just to go on, last thing. And the other thing that you might have noticed that is, as Jose, I think you mentioned in your video, that the blue and the red are the most are the fertilizers for the plants. One of the reasons a lot of companies are focusing on blue and red is because of the efficacies. Red and far red have the highest efficacies, and then you have blue. And then the white is basically phosphor, blue coated with either phosphor or you put a chip on board. So the more you move away from red, the lesser your efficacy is. And as you can see here, some of the top players, just focus on red and blue, and then as you go towards white, you see that you drop in efficacies. This is also one thing that we are, and there are quite a bit of studies that show that you need more than just red and blue for other parts of the plant growth, like secondary metabolites, aroma, taste, etc. If you need those things, you need to have a broad spectrum. The sun has a broad spectrum, so the indoor lights should have a broad spectrum. And with our technology, this is what we can do. We basically we know how to make these LEDs that are full broad spectrum at a very high efficacy. And so this is what we are producing at the moment, and we have already showed a lot of demonstrators. We have grown peppers in 100% LEDs, we have grown stevia, we've grown strawberries, so there's a lot of work we have done on this topic. So here's just an example of some of our work. We had peppers growing in 100% LED on the left. This was our old prototypes, but now we have more advanced lighting systems that we put in our grow chambers, and we can grow peppers. You can see that we have flowers and peppers, everything in 100% LED. Okay, that said, what are we looking for? Obviously, we're looking for partners with end users and also with some R&D partners in the horticulture space. We are also interested in sensor component manufacturers, and here our restrictions are a little bit more strict. We are looking for assembly components, 5-year lifetime. really small form factors, low power, preferably minimal heat generations. So yeah, ideally, if you can give me a multispectral imaging with all those parameters, that would be nice. But if not, yeah, we're looking even for imaging technologies or other sensing components. And then we are an agile company, so we outsource most of our manufacturing and foundry requirements. So we are also looking for foundry and manufacturer partners. And then again, we're also looking for, on the other side of it, we are looking for test partners. So we need to measure our light spectrums, we need to measure our efficacies, we need to measure our PPFs coming out of the light. So we are also quite in search of partners in that space. Yeah, I think, again, I also thank EPIC for giving us this opportunity, and also Optech BB, our partner in Berlin-Brandenburg region, who actually connected us with EPIC here. Yep, that is us. That's Crocus Labs, and I stop my presentation here.
Thank you very much, Crocus Labs, for this presentation. You are a very, very, very promising startup. We have in the back of the room Seoul Semiconductor and Osram. Thank you very much for being here. But I really wanted to give you the floor. Because I've been talking about wavelength fertilizers. And I think it is clear for us that we need to find a way of cooperating with this. When you talk about the potential R&D partners, dream away. What would be the most beautiful R&D project that you would like to dream with? And I will make it happen, I promise.
Well, most promising, yeah, that is interesting. Because I think for us would be nice to obviously get the Dutch University Wagener, because they do the most of the horticulture topics on the R&D topic. But also we are happy to work with guys like Osram or maybe even Inform. I think we know Inform a little bit because they are in Berlin. But could be also other vertical farms would be a nice partner. That's on the horticulture side, but also on the sensor side. If there are certain partners who are interested in putting their sensors into our test chamber, we can also do that. So we can offer our like smartHAPS. We could offer our light as a platform for some of the sensors to be tested, yeah, as long as they fit our requirements.
I'm going to find you partners. Of course, the floor is open for questions. So anybody who has questions can say hello. But I would like to say hello to somebody special today. We have a company, Quatergenics, in the room. Camille, are you with us?
Hey.
Yes.
Yes, I am.
I got very excited when I saw that you wanted to be in this meeting. Quatergenics is a very, very interesting company. I want to find you partners, suppliers, and customers in that order. So can you tell me a little bit what Quatergenics does? I know, but I want everyone else to know. Camille, what does Quatergenics do?
Yeah, we're more in the water quality monitoring space. So we're looking heavily into the agriculture industry as well. So maybe we should chat with Crocus Labs, because might be some synergy there for monitoring everything. Yeah.
There is indeed. Water quality monitoring, Camille, from Quatergenics. What technologies do you use for water quality monitoring?
Optical sensors as well. I mean, I saw in the great presentations today the idea of digitization of agriculture, and I think we're trying to make that happen on the water side, right? So getting the data points needed to be able to do proper analytics. Yeah.
Very, very good. If you are looking for any potential supplier of UV light, we have pushed a lot the UV light market for the water purification. If you're looking for shortwave or near-wave infrared, we have something that you will be quite amazed. And if you're looking for hyperspectral imaging, stay tuned, because the next presentation is out of this world. But before I go to the next presentation, I want to continue finding potential partners to this fantastic presentation that we have from Crocus. And I want to understand a little bit what Fraunhofer CAP, and we have a really good person from Fraunhofer CAP in the room. What Fraunhofer CAP is doing as R&D projects in the field of agriculture. John, thank you so much for being with us today. John MacArthur from Fraunhofer CAP. What brought you to this meeting, and what kind of cooperations can we start with Fraunhofer?
Yeah, hi everyone. Yeah, great presentation so far. So we're a photonics applied R&D service. We don't have technologies as such that we provide. We have research capabilities. At the minute, we've been working with a small startup in Sheffield on a growth chamber and providing input to their multispectral imaging system for that, analyzing their light spectra that they use. And yeah, we're just looking for various startups that have hyperspectral, multispectral imaging needs.
You've been involved in fantastic R&D projects in the past years for standoff detection of any chemicals for many different application fields in the defense, but also in the agriculture side. When we talk about the standoff detection, is any particular ongoing project, any particular interest for cooperation?
Yeah, quite possibly. I mean, I think during the last, 6 or 7 years we've been going now, we've had standoff detection projects everywhere from the ultraviolet right up into the far infrared, and pretty much everywhere in between as well. So whether that's standoff Raman detection, various hyperspectral imaging in the kind of mid IR with OPO technology, QCL based far infrared and thermal imaging, and like I say, we're not a technology, we don't have a specific focus that we're trying to force on folk. We look for the best solution for the
Thank you very much, John, for this, and I will come to visit you. We have to do something with you. Before I go to the next speaker, I would like to understand, when we saw a company that wanted to register for this meeting was Huawei MRC, and we really wanted to understand how we can help them and what was their interest in agriculture. This is a unique opportunity for us to learn a little bit more about this story. Yasar Kutubantavida registered from Huawei MRC. Yasar, thank you so much for being with us this afternoon. What brought you to this meeting, and what interest do you have with the supply chain of photonics for the agriculture sector?
Hello, Jos. Hello, all. Thank you for a very nice presentation and for the introduction. Actually, Huawei is not seriously into the agricultural photonics area at the moment. I actually joined to see what is happening and what is the requirement in the agricultural photonics area, or because we, as you know, we are experts in sensors, we are expert in digitalization, we are good in interconnection. So we are looking forward for how we can support the agricultural photonics or agricultural sector. So because we are actually very new in this area, so we have not yet stepped into this area. So we just want to see what is happening and what are your requirements and how we can support you.
Thank you very much for this. We're going to talk a lot about an interest that I know is very important for the consumer electronics market, which is to bring hyperspectral imaging into consumer products. I want to understand how we can do this, but before that, I want to go to one of the success stories that we have in the hyperspectral imaging sector. We go to one of my favorite companies in EPIC. We go to Finland, we go to SPECIM, and we hear from Mathieu Marmion. Mathieu, thank you very much for being with us. You're the senior application specialist looking at the agriculture market at SPECIM. Thank you very much for being with us, Mathieu. The floor and the attention of everyone goes to hyperspectral imaging, goes to SPECIM.
Yes, hello. Thank you very much, Jose, for this introduction. Also, thank you very much. So we put the presentation mode. Also,
he comes with all the energies like me. This is great. He comes energized. I love this.
Yeah, sure. I mean, you have to be full of energy still, even if it's like quite late at the evening, but still. So yes, thank you very much for the EPIC team like this to organize this kind of event. So I'm happy to be here and to present our product we are expecting for. So just a quick presentation about SPECIM. As Jose was explaining, we are mostly based in Finland, in Oulu, and we also have an office in Barcelona. We're also present in the United States, in New Jersey, and also in Detroit. We also have an office in Shanghai, so it means that we are all around the world. We have also a network of distributors. We are about 70 employees, and we are not a startup anymore. I mean, but we have been before startup, but now we are like 26, it's written 25, but 26 years old. And this is what we are. And we are making hyperspectral cameras. All our hyperspectral camera line scan devices, except the IQ, but the IQ, we'll speak about it a little bit later. The scanner is integrated inside. So basically, we are making hyperspectral camera, which are line scan device, and each pixel of the line having independent spectral information. I think all of you know already how it works, but basically with hyperspectral camera, you can measure spectra And because different molecules, they have different structure. So basically they will not reflect the light exactly the same way. So then it's possible a bit like the fingerprint approach to separate, different type of component or even to check chemical composition. We are making hyperspectral camera, which are ranging between 400 nanometers and even to the thermal infrared. I'm sorry, I did not include it here in this presentation, but because what you were talking about before, it would be something interesting. We're making camera up to 12 micrometers, but for most of the agriculture-related application, we are making those. So the IQ, which is somehow a portable one, between 400 and 1,000 nanometers. Then we have the FX cameras, the FX10, the 17, which is between the VNIR and also the NIR spectral range. And then we have at the top of that a bigger brother, which is a sphere camera between 1,000 and 2,500 nanometers. And that was for the left-hand side of the presentation, which is more like for the industry and also for the laboratories. And on the right side, we have more the system which are dedicated for the airborne application. So we have the ISA Kestrel number 10 and require like a payload of about 5 kilos if you add the GNSS IMU unit with it. Really high quality device. We also have the AFX10 and AFX17, which are really the compact version. They are based on the FX10 and the FX17. It includes already inside the GNSS IMU unit, as well as a disk for saving the data. Then for even bigger platform, we are having here the Phoenix, which is about, if I recall well, 12 kilos. And this one is the full spectrum between, it says 1,000. Sorry, it's between 400 and 2,500 nanometers. And we have two versions. So this one is really the full spectral range. And then the last one, we have the EBIS, which has a really tiny spectral range between 670 and 780 nanometers. This one is really dedicated to look at really where atmosphere is absorbing all the incoming light coming from the sun, but still the vegetation is having sun-induced fluorescence. So with this sensor, it's possible to measure those. So as I say, we have those cameras which can be used in various environments. Could be like in a laboratory. We are providing, for instance, scanners where the camera could be mounted at the top and then the sample is moving underneath. We have also provided camera for greenhouses. Also for the field, like the IQ here, I don't have a real photos, but still it's a schema. You understand really well how it works. So you just put IQ on a tripod, can take a picture of your field, and then you can get the hyperspectral image. Also, the camera can be put in a UAVs or in an airborne platform like this, like in a pod. And for industrial application, basically you recognize the FX camera here at the top of the conveyor belt. And then again, with an automated system, which is behind, it's possible to sort, to detect some contaminant or even to check some quality control like fat content, oil content, things like this. So basically the different type of application could be like precision agriculture. So as you can see, with a full spectral camera like the Phoenix between 400 and 2,500 nanometers, you can really measure how the health of your plants can influence the spectral signature. And for example, the chlorophyll content has a really strong absorption feature around 550 nanometers. And with the Phoenix as a dedicated camera, you can really look at it. Also, the water content can be seen like for a bit longer wavelengths. And I was talking about the sun-induced fluorescence with the IBIS, which is the image which is at the bottom here. So you can recognize really well an agricultural area with different type of fields. And again, with the sun-induced fluorescence, it's possible to pick up and to see like this, where you may have a pest or where you have a disease or just simply how well it just grows. And also, of course, it's kind of precision agriculture, but for the crop yield and quality monitoring. Also, what we consider like our camera, it's for the food chain, but not only from the agriculture, we can go a little bit further in the processing. So with hyperspectral camera, you can make qualitative and quantitative data analysis. So qualitative, for example, on the right-hand side, you can separate contaminant of the shell from the nuts. And also in a quantitative way, then you can really measure what is the percentage of fat, of moisture, or these kind of things with the hyperspectral data. What is very interesting with hyperspectral imaging is that when you can combine different sensors together, which are complementary, for example, hyperspectral and X-ray, then you can really make some system for packaging inspection. As you can see here, only the X-ray will not be able to do it. RGB camera will not be able to do it, but hyperspectral plus X-ray together will be able to do it. And finally, we just released a new platform. So basically we provide mostly the camera, but then for industrial application, we understand there is a gap between the camera and actually what the user needs to do, like to get the interpretation of the data. So here we come with the SPECIM1, the SPECIM cube. So the SPECIM1 basically is a combination of the hardware, which is here a processing platform, the SPECIM cube, and also a processing software to build a model which can be then run in real time, like to make quantitative and also qualitative data analysis. So basically, this is what I had to say. What we are looking for, we're looking for partners who are able to integrate our camera for their applications. It could be industrial, it could be like in greenhouse, it could be in the laboratory, in the field, and also to transform the products, as I say, for the agriculture, like for the food. Do you have any question?
Mathieu, thank you so very much for this great introduction to the hyperspectral imaging and what it brings to the food industry. So there is a lot of possibilities there. I'm sure that there are a lot of questions which people are still thinking on. So let me try to ask you this, because for hyperspectral imaging, you have a lot of applications, and depending on the application, you get different data, basically. But when it comes to, let's say, food inspection, how deep you can look with the hyperspectral imaging, how well you can analyze the product with respect to all the chemical composition which is in there?
Well, first of all, it depends on the product you are looking at. For example, if you look at a product which is really opaque, you look at the nuts, then you will see only at the top of it, let's say like few micron will be the penetration depth. Having said that, if you go to longer wavelengths, if you go to the NIR or the shortwave infrared, even to the thermal, then you can see a little bit deeper. But then you can have products which are fairly transparent. If you think about a fish fillet, if you think about some fruits. So for example, you can have an illumination that you can see almost through. So here you could see much more actually. So, and also you can use a hyperspectral camera in a reflectance mode. So basically you have the camera and an illumination at the same side, but it could also be in the transmission mode, having the illumination underneath like this. But as a rule of thumb, I would say like hyperspectral imaging is the surface measurement unless your sample is transmitting.
Okay, thank you. And when we construct cameras, of course, we also need to think about filters and optics. And today with us in the room, we have Thierry from SILIOS. Thierry, would you like to introduce SILIOS a little bit and what you do for the Agriphotonics?
Okay, and you hear me, all of you? Okay.
Yes, we can hear you.
Okay, so I'm gonna just present you very shortly my presentation, but 2 slides, very quickly. In fact, SILIOS, we're an SME in the south of France, and but I don't find my slide. Anyway, I will do without slide. Okay.
No, Thierry, just show the slide. Don't worry. We are not gonna rush this. Before when you prepare the slide, I'm gonna talk to one of the companies who has been made quite a lot of interest on this market. I'm gonna talk to Hype Solutions. Thank you very much for being with us today, Tobias. We've been discussing in the past. Hype is very, very promising. When you hear the presentation from SPECIM, they made it there. You are in the process of getting there. What do you want your medium value to come? I see that the slide from SILIOS is already prepared, so I will come to Hype later. Thierry, the floor is yours. Go presentation mode. Please.
Okay, thank you. So, okay, we're an SME, as I said, in the south of France, close to Aix-en-Provence. And in fact, we are doing micro optics. So we are making multispectral filters for snapshot. But aside of it, we're also making small cameras, let's say the CMS series, CMS4 series, and also we make a lot of custom camera. So here we were speaking about agro-food industry and agriculture. I would just present you that some cameras that have been used for proxy detection in smart agriculture. So one has been used, is the CMS4 to detect. In fact, all of those are being used currently to early disease detection. The example of the CMS4 used by Wageningen University and Research. Here they look at some pest or some, let's say, disease in orchard, in apple trees, and you look with an RGB, it's difficult recognize as just with the full color presentation, thanks to the multiple wavelengths that we look at. It's much more easily detected and easily to be sent to a let's say a neural network discrimination software. So here you see the RGB image, and here you see that with the artificial intelligence, they detect very easily the disease. Same again, but all of them are used for proxy detection, because with the drone, of course, you cannot pass very easily under the canopy of the trees. So in the vineyard, same camera, but with less spatial resolution, only 1.3 megapixels. Here that was 4.2. There is a detection of SK, which is a disease, but also flavescence dorée, which is killing, let's say, many vineyards in Europe. And finally, also an example to detect fusarium on the wheat in the field. So here you see let's say of course the intelligence of artificial intelligence is for GVS and INRAE. So it's and then it has been used to detect fusarios and to qualify the seeds. So here you see that the plant here is attacked, and here it's still sane. So that's the example of what we have done for agriculture. So you have my coordinates, but also we have, of course, many other applications, but here.
Thierry, you are one of the key people that we have in EPIC in this, what I call the European micro-optics revolution. We are really going to enable so many different markets, and SILIOS, when you're looking for customized micro-optics, it is one key company in our segment. But I want to go now back to SPECIM, and I want to do business. From the presentation from SPECIM, there is a lot of possible cooperations. I would like to ask you, is there a particular interest on the optics, micro-optics? Do you have some challenges on this? And then afterwards, I will read you the questions from YouTube.
You mean who to speak? Me?
No, from SPECIM, Mathieu.
Oh, okay.
Yeah, sure. I looked at the presentations. That was interesting. So us, we are making like mostly transmitted grating. So I don't know if here it's matching perfectly well, but I have seen already like this presentation. I think it was at the SHE event, and that was really interesting. And I remember that.
Transmittance gratings. Do you need any particular coating on that? What kind of material do you use? What can you share on this? Because we have great technologies on this as well.
Yeah, in fact.
Sorry. Please.
Yeah,
please go ahead.
They are quite different. In fact, with SPECIM, they use diffraction gratings. Okay, and us, we just put, let's say, between quotes, Fabry-Perot filter onto the detector. So it's completely different technology. In SPECIM, as far as you will tell me if I'm wrong, it's mainly push broom camera, and by us, it's more snapshot. We can do also.
You're correct.
It's more snapshot application.
That's right. Okay,
yes, you are correct.
Yeah, but let's talk for a second about the about the diffractive gratings that SPECIM is using. What kind of material, what kind of technology, and is there interest for coatings, for filters on this?
Well, we have mostly need in terms of gratings, about lenses as well. When we are talking about like prism and gratings, it depends as well on the spectral range we are talking about. We are talking about between 400, but we are making sensor in the thermal infrared, so up to 12 micrometers. So there, there are different material which has like different transmission. And here, of course, we are looking for partners able to make like an optical component for this full spectral range. Yeah.
Let's look for you for partners and also for clients. Sumitomo Electric just posted a question in the chat. Yoshiaki Shikata-san, is the higher frame rate important factor for hyperspectral imaging in the shortwave infrared?
Yes, because if you have a fast frame rate, that means that the conveyor belt, if you are, for example, in industrial application, can go even faster. So it's what we were explaining. We are making line scan device, so you take a line like this at a time. So if you have a conveyor belt which is running really fast, so you need to have a camera with a fast frame rate. So it is really needed.
Another question in the chat. This is from Genoa University. They are working in many wine applications, and they are wondering how you can separate the information of the sun-induced fluorescence from the overall broadband illumination contribution.
Ah, that's interesting. So basically, you know that the sun-induced fluorescence, it's about 2% of the signal. You know that we are looking exactly at the bands where the atmosphere is cutting, you know, the sunlight. So basically, if you have a signal, it cannot be a reflection because there is no incoming signal. So if you don't have incoming signal, the signal you get is necessarily due to the induced fluorescence. That is the way we are doing.
All right. Now I said suppliers and also customers. Let's go to the potential customers. We do have a very, very interesting company in the field today. It's called Syngenta Seeds. And Jan, goedemiddag Jan. Jan is here representing Syngenta Seeds. I would like to ask him a little bit about the kind of possible collaborations that we do. Jan, are you with us this afternoon?
Yes, hello.
Goedemiddag, Jan. Thank you so much for being with us. What brought you to this meeting and what interest for cooperation with the supply chain we can do for Syngenta?
Well, I was attended to this meeting via Seeds Valley, and we grow indoor vegetables. And so I'm interested in line recipes for how to induce flowering in vegetables, because I want to have my vegetables in flower. For example, lettuce or cabbage or tomatoes, whatever.
If you are looking for a potential partners, very end user here, this is a key interest from that. We are talking here for inducing flowering. Most of the time what we do need is to fully monitor fluorescence in the flower. Is that correct? That's the real interest, right? Fluorescence monitoring.
Yeah, for example, I'm still in the beginning of this journey. Now I have to find out why some lettuce do flower in 9 weeks and other fail to come to flower within 19 weeks under the same circumstances.
We do have fantastic technologies for this in EPIC, I think. Do we have somebody from Ipsen Photonics in the room? Is there anybody from Ipsen Photonics? All the way from Denmark.
Sure.
Of course, Thomas is here.
Yeah.
Ipsen Photonics. We are hearing here about real-time monitoring of fluorescence. What comes to your mind? How could you solve Jan's issue, Jan's headache?
Yeah, so hello everyone. So at Ipsen, we are a manufacturer of spectrometers and diffraction gratings. Actually, we do also make transmission gratings like SPECIM is using. Yeah, we do really tiny spectrometers for fluorescence that we call pebble, like small stones. So I think that might be an option. I think we're at least moving down, like somebody else asked before, starting to use SMD-mounted CMOS detectors. So the spectrometer is still bigger than an SMD component, but at least it's using it for very small and tiny components. So that might be something to talk about.
Let me release a challenge to the whole photonics community. I love doing that. If anybody knows technology for real-time fluorescence monitoring and also for just monitoring the flowering in a crop, you have to contact Jan. You have to contact Jan from Syngenta Seeds. Thomas, it's great to see you again. I would like to go now to another company that I'm very interested of knowing what we can do for them. The company is Fritz Meyer. And from Fritz Meyer today, correct me if I'm wrong, I have somebody who is from Fritz Meyer. I have Martin Bucher. Martin Bucher in the room, right? Martin.
Hello.
Looking fantastic in your living room.
Nice
what brought you here? How can we collaborate?
Yes, so basically Fritz Meyer is a solution provider for conventional agriculture at the moment. So we are on the one hand developing sensors for in-the-field measurement on tractor mounted basically. And then we are also providing software, the necessary software platform to process those sensor data and additionally satellite data and combine them to optimize the input control for the farmers. So like fertilizers, other chemical inputs, and optimize yield on the one hand and also economics for the farmer, but also we have an environmental impact since we are optimizing the input use efficiency by the plants. So, and my objection here in this meeting is basically that on the one hand, we are looking for components, sensor components. On the other hand, we are also looking for different applications we can expand to, like indoor farming, we heard, for example, a nice presentation already from Crocus Labs or something like that direction is also every time or all the time interesting for us to see what's going on there and how we can expand.
Martin, be prepared for a lot of female introductions because you obviously have raised the alarms of all the companies that we have in EPIC preparing sensors. Back to Mathieu from SPECIM. We do have, Mathieu, a lot of end users who are in the room, but today, given the sensitivity of the topic, they wanted to remain anonymous. And one of those end users just sent me a text with a question. Could you tell us some of the benefits of hyperspectral over other type of cameras, for example, simple near-infrared camera looking at moisture?
Okay, so actually this is a common question, like, can you point out the benefit of hyperspectral compared to multispectral or the other ones? So basically, when you are with a hyperspectral and you look at the moistures, there are different peak of absorptions. There is, for example, 970, there is 1400, and there is something as well at 1200 something, if I recall well. So with a hyperspectral camera, you can not only measure the difference, in the depth, like what is the absorption depth, but you can also measure what is the slope. Like when you are diving with your hyperspectral peak. And here it may give you as well some information. But I would say for moisture, it's not really where you have the strength of hyperspectral. The strength of hyperspectral, it is the ability to measure many things, not only one, but many things with a single sensor, and to have the ability to adapt to the needs depending on what you are doing.
Thank you.
Flexibility.
Thank you very much, Mathieu, and congratulations, because SPECIM really is making a difference on hyperspectral imaging. And thanks to companies like you, hyperspectral is such an amazing technology for the future of the European industry. Thank you, Mathieu. But I want to go to one company who is a few years behind you, but also with a lot of energy. I want to go to Hype Solutions. Hype Solutions is one of these startups that they get super excited every time I talk to them. I would like to know what is the current status of development for Hype and what kind of companies you need to make Hype a great company, even greater.
Hi, Jose. Thanks for the invitation. Currently we provide various, so to say, user-friendly hyperspectral solutions. So we really focus on the end user, on the end user application. We have quite a portfolio right now, so 5 different products. We have solutions for the drone. We have solutions like in the phenotyping industry. So basically an analysis box where you can measure in very controlled environment. But we are also currently developing a handheld solution, so very mobile hyperspectral camera, which can be used also by people who are not really into hyperspectral technology. So very easy to use and handy with integrated LED lighting unit. And we are also currently solving problems in the sorting, food industry, recycling industry. Basically, most of our customers currently also from the Agriphotonics industry. So we are looking for people working with our sensors, especially also with our sensor with our drone solution that we have. So we implemented our sensor on DJI drones with a very easy to use workflow. So we are open for discussion in that area.
Oh, let's have a discussion. Also open for discussion, Tobias. I have seen the handheld hyperspectral camera with the LEDs. Quite an interesting technology. I want to see if there is a way to test it with an end user. Martin Bucher from Fritz Meyer. I pay for the shipping expenses. Can we have a test on the run? Martin Bucher from Fritz Meyer. I think he's trying. I think we're having some problem with the sound. Or after his presentation, he said he was done. No, he's not done. I will come back to Martin, but I want this to happen. I want to make sure that we make a test run for this. Why don't we go now to the next speaker, and then we continue this amazing discussion. We heard from end users already like Fritz Meyer about potential cooperations. We heard about different technology being supplied. We even had Syngenta seeds looking for optical sensors. Let's now bring HORIBA to the mix. And from HORIBA, we have Brice Villier, design authority and spectroscopy expert. And that when you say that at HORIBA, that's saying a lot. Brice, thank you very much for being with us today. The floor and the attention of everyone goes to HORIBA.
Thank you, Jose. Thanks a lot for this meeting. It's the first start for me to make this kind of meeting online. So I hope I will be able to do that. So let's share my screen and start the presentation. Up.
Let's see. I'm sure we can manage. I went to visit HORIBA in Paris. Yes. It was an amazing experience. Brice, the presentation is coming. Just go presentation mode. Congratulations on your 202 years.
Okay.
And let's see if we can go presentation mode now.
I will switch.
I think you might be sharing the wrong screen.
Yes.
No. Yes, you are.
Maybe it's okay. Okay, so yes, it's also now we are in 2021, so it's a little bit late to speak about that, but we had, I would say, the great joy to make our 200 years of optical innovation in HORIBA. So I will start, because HORIBA is a Japanese name, you know, but we are, in fact, a very French company for a Japanese company. Okay. So basically, HORIBA is a Chinese group who is working with different segments. The division where I'm working with is mainly about scientific applications. And we are located in France, nearby Paris, and we were called as Jobin-Yvon Company, which started with a very famous customer like Augustin Fresnel's to make the lighthouse in 1819. We are now within the Japanese group of HORIBA since 1997, and we are global leader in Raman spectroscopy, AFM, electrometry, ICP, and various kinds of, I would say, lab instruments that are not necessarily open to the online field. So in my case, I'm running to this scientific segment. The kinds of activities that HORIBA Scientific has is that we are starting from components to instruments. So we have a passion for what we are doing. We are working in collaboration with our customer, and we are always trying to make some new innovations. So in particular, inside the HORIBA Jobin-Yvon product portfolios, we are #1 for Raman spectroscopy, but all the kinds of technologies are also relying on the diffraction gratings and all-around optical device that work around these kinds of business segment. So I can just giving some few words about the diffraction gratings. So because here we are speaking about hyperspectral and agronomy, and you have to know that HORIBA is making hyperspectral cameras for now than almost 50 years. So before it was called just imaging spectrograph, but we have more than 50 missions flying already. I would say the most well-known is that for carbon observatories, we have many projects with NASA and ESA. So we have been designing hyperspectral camera for years with different kinds of budgets, of course. But it's giving us some large experience about the designs of these kinds of very costly and very difficult missions. Apart from that, we have an OEM activities for the industries, and we have a large portfolio of OEM replica gratings. And we are going up to the replications of a few thousand pieces per year. And we are a leader for aberration corrected gratings and also for convex type 1 gratings. So the convex that could be used for Höfner design, by example, or for Dyson designs. We have a constant performances and traceability in our products thanks to our medical activities. We are on one of the only players on the markets that is being able to deliver and manufacture their own master gratings. So it's really critical to design a new hyperspectral camera, and we can really go from scratch. So it's really what our customers are requesting that is at the basic of what we will do from the grating design. So we can work in various spectral range. We have some specialties in the UV. So for example, the Alice UV spectrometer on Rosetta is containing some Jobin-Yvon gratings, some HORIBA gratings. We can do diamond turning, and start to very low groove densities, so like A-shell gratings from 20 grooves per millimeter, so very low dispersions to use in very high orders, or up to very high, I would say, and very selective gratings. So the one, for example, that could be used for fluorescence, as I said before. And we can make it on various kinds of substrates. So we have some substrates flying in silicon carbide for space application, but also glass, metals, aluminum, and whatever is required. So I would say that we are really a specialist about diffraction gratings, and for space gratings that I would say more than 50% of the missions are hyperspectral or multispectral. Maybe one thing which is a little bit different from the other players here is that we are really OEM manufacturer in the sense that we can customize everything. And that's the ADN and the DNA, I would say, of this of the OEM division. We can tune everything for our customers. The drawback for that is that, of course, we are generally working with recurrent orders and so big customers. So we don't have really, I would say, extensive standard products on the shelf. We are really working in collaboration with big players on the market. As I said, regarding this industry, that we are constructing a new blocks, like I would say, all the players in this field, is that we have now more and more industrial interfaces. We have more and more focusing on SDKs, but also on real-time and smart real-time embedded processing. So now we can include in our products some AI and standard chemometrics algorithm for real-time, I would say, and online sorting of our products. We are also putting a lot of, I would say, accent on the performance of our products, in particular of the reproducibility from one unit to another. So if you have one spectrometer or 1,000, you could use the same kinds of modeling and so on. This is a very, I would say, unique part for us, is that we are focusing on volume orders. So this is the kinds of examples of the products we can manufacture. So you can start from, I would say, a good whole monochromator, which is a rotating grating, which is scanning the spectral range, and I would say purely offline measurements. So to be able to make the measurement of moisture, protein, gluten, and any kinds of I would say, parameters that are interesting the several industry players, and for the storing and for also the pricing, which is very important. We can also develop this hyperspectral in another approach, which is the multi-channel. So we have plenty of approach. So a camera could have a look at different points in the field. You can put some fibers and then getting from 30 to 90 channels that could be processed in parallel. These points could be used, for example, for the seed sorting industries, where you have to be able to distinguish some particular things around the seeds, because you just want to sell seeds that will grow when you're a seed producer. Regarding that, we are also working, I would say, on very small and very compact spectrometers that is mainly used for water analysis currently. So starting in the UV and up to the NIR. So for the water quality measurements, and also for the NIR for the moisture and the protein contents. We can have also very high resolution spectrometer down to 0.6 nanometer for very specific applications. So this is just an example. So I think that there is companies that are interested in water and specialists about water analysis. So this is typically a very large growing market using spectroscopy, because spectroscopy is giving lots of information at one measurement and for, I would say, a moderate cost. So for example, you can detect some pathogen, lots of chemicals. You can analyze for the turbidity as shown below. So you can either make some colorimetric measurements and to replace some tests that could be done by operators, by eyes, which is not that safe. And we can work on different kinds of products. So main products are probes, but it could be also some device, I would say some labs apparatus, or even some embedded systems. So we have some customers that could put that on autonomous systems in ocean, for example. So I think probably this is probably one of, I think something that is really of interest for the next photonics industry, is that, of course, we know that water is a key point for the agriphotonics and for the agriculture in the future. And also the wastewater management and the quality of the water would be one of the biggest issues. And that's what we are seeing worldwide, not necessarily in Europe, but also a lot in Asia. We can develop other kinds of spectrometer, I would say either hyperspectral or either single points with scanning systems. And that are applied in the waste sorting, for example, but also in hyperspectral and fruit sorting. So here it's really just examples about existing platforms that are running at our factory and the kinds of applications that could be addressed for that. What I would say is that today we are really efficient in the hardware manufacturing, and for the modelization, this is something which is coming and where we are learning and where we can collaborate with our customer or with partners. We are already, I would say, dedicated on the hardware manufacturing. So just give us your specification, give you your constraint, and we will try to make you the system with the target cost and for the target volumes you have. One of the key things I see, and as I said by Sumitomo, I think we are now working on very, very high frame rate, push broom, hyperspectral images to be able to make online applications. And this is something where we are just at the start, and I think where the speed required to be able to follow the standard process is just beginning to happen thanks to the sensor manufacturer. So I think there is a bright future for NIR hyperspectral in our future. So thank you.
Thank you very much for this great overview and introduction to HORIBA and all this really great technologies that you're developing and all the different applications you're looking at. So with that very broad overview, if we come back to a little bit narrow topic of Agriphotonics, I would like to come to you with what we call epic question. So on a nutshell, we have that many people in the room today, and we also have almost 700 members in EPIC network today. So what you can do for them and what they can do for you.
Okay, so today we are already a manufacturer which is optimized for small and medium volume. So typically we are working for custom designs to solve customer problematics for, I would say, some quantities between 100 and 1,000 pieces a year. So our target is not to make the application discovery, and there is plenty of, sorry, I maybe stopped sharing. There is plenty of very nice player that really knows well the applications and so on. Today, our target is mainly to be able to develop, I would say, a cost-effective hardware on industrial scales. And today we can provide hardware, we can provide full solution for some markets. So today, my first target is to find partnerships with people, for example, big companies that have one problem to solve, and I would say to a medium scale, and where we can develop a business, develop some products for them, and to solve issues while optimizing the cost and optimizing the performances.
Okay, great. So we can develop quite some partnerships over here, I guess. So let's see what we can do. We have today with us Monica in the room. Monica, do you have something to comment also to what Brice is looking for and what he presented to us?
Hi. So I'm part of a group that is launching a creative industry hub in Portugal. And my role is to identify emerging technologies that we should bring to our country, mostly dealing with creativity and ecology and sustainability. And I've foreseen in the photonics and all these technologies you were presenting, something that will be important to both have a better connection with ourselves and the ecosystem, and also to digitize and optimize the production of food, especially inside houses. So since you are the tech developers and the researchers, we would like to support you and doing demonstrations in Portugal or upscaling. So here is my contact. If some of your companies or research groups are interested in coming to Portugal, please contact me.
Thank you very much. Well, we have yet another site where to go for the new development, which is great. We also have today with us in the room a company which is called Opsin, and Daniel Plant, who didn't find a better way of celebrating his birthday than joining an EPIC meeting. So Daniel, why wouldn't you show us yourself and share a little bit what is Opsin all about? And don't forget to unmute yourself before you talk. Or he became too shy. Oh, and then probably we'll get back to Monica a little bit later, or to Daniel a little bit later. So let's keep going. Keep going with the great discussions over here. We also have Stephen from AdMessy who joined our great meeting like last moment. So Stephen, how do you find it so far, and what AdMessy has to offer in the Agriphotonics?
Well, to be honest, I'm basically spying on most of you guys a little bit. We come from a little bit of a different background. We make mainly measurement equipment for color and light measurement in electronics, such as displays and LED lights in consumer electronics. But we are now looking into expanding into different markets. And one of the markets we think is very interesting for any photonics application is agro-food markets. So I was basically sort of picking your brains, and I find it very interesting to see the broadness of applications in this market. And so I hope to basically have some interesting updates for you in, let's say, 3 to 4 months, as we will be launching a new platform then, which I hope to work with several of you to bring that to the real applications. But for now, I'm mainly picking all your brains, but I'm learning a lot, so that's very good.
Well, wish you successful spying until the end of this meeting, as there is still some more to come. And we also have a young company who joined EPIC not too long ago, Nairos, and we have Shen with us. Would you like to say a few words?
Yeah, hi everyone. I'm Shan. I'm the business developer for Nairos. We make hyperspectral cameras and multispectral cameras, and in the upcoming meetings, we will be launching our product. So at the moment, I'm also learning about our competitors and different applications. So I would like you all to stay tuned for us to launch our products. And thank you so much.
Thank you very much. So we have quite a bit of spying going on over here. So maybe in the spirit of spying, let's go and fish for some more information going on. And we'll go to the presentation of Mauro from MantiSpectra to see how we can make the sensors as small as they get to still give the best performance.
Thanks a lot, Elena, for this nice introduction. Hope you can hear me.
Yes, we can hear you very well.
Let me see.
Now we also want to see your slides.
Cannot see the
PowerPoint. At the
PowerPoint.
bottom, green button, share screen.
Yeah, but I don't see the PowerPoint among this, but I can just share my desktop. Probably it's the best solution.
Let's try it out.
Second. All right. This one, right? Can you see it?
Not yet, but I think it's coming.
Is this one? Can you see it?
You are not sharing your screen yet. So
yeah.
So you just need to start share also after you choose the screen.
Yeah. Can you see it?
Now it's coming. Now we see your desktop.
Which one? The black one or
the black one?
All right. Sorry about that. Yeah.
Okay, now we see presentation, only missing the presentation mode. We are almost there.
Let me see if I can switch the presentation mode from.
Sure, you can. There is also a button at the bottom, or there are other options.
Cannot see it.
If you go in view.
Stop video. No. Well, maybe I can just use this. Well, if you can see my screen, I can just.
You can see it, but let's still try to solve it. At the bottom of the presentation, there is a little icon which looks like like a presentation mode screen.
You know what? When you solve this, I'm gonna get my team to solve this offline. I have a question from the YouTube universe going all the way to HORIBA. Brice, Villier, there is somebody who wants to ask you something in the chat, all the way from Italy. They are asking, are there a lot of? Sorry, there are a lot of spectral-based detection stages, but are you aware of any particular? Are you aware of any particular applications of polarimetric sensors in agrophotonics? Polarimetric sensors.
Yeah, so spectroscopy is a little bit hard, and then you introduce polarimetry spectroscopy. Okay, that's a nice challenge. I'm not so sure right now, but yes, now there is some technical possibilities, I would say, to also measure polarimetry. I don't know exactly, but I'm sure that there is plenty of very interesting to add to polarimetry inside spectroscopy. Because polarimetry generally relies to patterning and to some axes and to symmetries from the structure. So of course, knowing something about the structure has probably a big interest. But now for particular applications, I would say I don't know. But let's have a discussion and let's try.
Brice, it brings a hint here. The people who are asking are very interested in the wine industry, and they want to monitor the flowering of the crops. So I have the feeling, but we're going to discuss this offline maybe between you and them, that their main challenge is that they don't get enough with the fluorescence measurement. But we will discuss this offline. I want to give the floor to one of the most amazing startups I have come across in the last months, coming all the way from Eindhoven, Rock City. These people have managed to make a spectrometer on a chip, and actually it's based on the integration of different detectors tuned to different wavelengths. The floor and the attention of everyone goes to Maurangelo. Goedemiddag, Maurangelo, the floor is yours.
Now, can you hear me? Can you see the screen?
Loud and clear, Gorilla Glass clear, everything is ready for you to rock.
So, we all had technical issues this week, so we had some of them. As you can see, what we developed in our university is a tiny spectral sensor. You see a picture here, so tiny that can fit, can stay on the finger of, and what we have developed is clearly summarized by Jose. It's a multispectral sensor. We have several wavelengths spanning from 800 to 1700 nanometer. We use this sensor, to perform, to do measurements similar to what you do, to what has been done with spectrometers since many years. And then, as you know, there are many different applications out there for spectrometers. Today we are here to discuss about agriculture, but as you know, the spectrometers have been used for decades, actually, in many different industries, from food to pharmaceutics to healthcare. Also, new markets are emerging right now. In particular, we see some interest, for example, in the consumer market, smart home appliance, where they want to employ sensor for both classification, but also quantification of material composition. And we have heard about the near-infrared spectroscopy. We have heard that actually this provides a very fast, not invasive, and contactless way of measuring materials without bringing the sample to a lab. What we have done, actually, we have developed a tiny chip made of, again, several pixels. These are not actually imaging systems, so it's a single point detector in which we measure 16 pixels, and then we use some advanced machine learning to retrieve the chemical composition of material, for example, a tomato shown here, just again by measuring 16 numbers. And as compared to other technologies which are there, this is actually one of the few technologies that provides a fully integrated solution, so both detectors and filters at the wafer level. And different from other spectrometers, we measure only the wavelengths that you need, so there is no moving parts. This is important, for example, in applications that we've seen today, for example, where we have moving parts, robots, or when you really need a rugged solution. And this is mainly needed for example, on the field applications. And yes, since it is based on semiconductor and standard semiconductor technology, it has the potential to scale to large volume production. So we can produce many chips on the same wafer. And we actually develop not only the chip, but also, let's say, the full system that you need to operate this kind of spectral sensor. So we have now an OEM solution where you can just read, let's say, the detection performance just via USB cable. We have also the capability even to, let's say, produce and test the model directly with this solution, and the possibility to embed the model that you can create directly on the microprocessor. This is very important for many applications, as we see out there. And also, we have developed what we call SpectraPod, which is actually a handheld solution which has everything included. So it has illumination, optics. At the moment, it is USB powered, And again, you can use this device directly on the trees, directly on the field, directly in greenhouses. And in particular, you can use it as a handheld device. Well, of course, I'm happy to answer your questions. This is actually my email. Let's hope that we can bring together spectroscopy to the field. And spectroscopy, again, has been there for many years, since 1960. And actually, Agriphotonics was one of the first applications. So we see that this has a great potential, in particular, to explore new markets when, again, you can combine this technology also with robots and also with traceability and blockchain solution as well. So at the moment, regarding the EPIC questions, well, this is our offer. We're looking also for partners that are more in the traceability market, and they have developed already cloud solution. You can combine these solutions, physical solution with some digital solutions that are already out there. Thanks.
Grazie mille, Maur. Thank you very much for this fantastic presentation, and thank you for being innovative in this industry. I am amazed of what you have put together, and I want to help you even better. You've been looking for potential customers. We introduced you to many, and everybody's getting great. We are receiving great feedback. But give me one challenge. It's not easy to put this integrated spectrometer on a chip in this instrument you showed in the last slide. Give me one challenge that the companies in the group can help you with.
Well, in the scaling up process, of course, now we are scaling up. We are a startup. We know very well how to produce the chips. We know how very well to also integrate the system, leveraging on the ecosystem that is around us. What we are developing and what also you saw on our slides is more like a cloud solution. So we like to find opportunities where we can combine this, let's say, physical, chemical technology with digital technologies. So again, looking for partnership more to embed the systems already in a platform and in a digital platform.
We are going to make sure that Martin Bucher from Fritz Mayr, who was here and told us about the different cooperations, I'm very interested in you trying your sensors in their platform, in their agriculture platform, and this is going to happen. I want to have now a little bit of a discussion with some of the companies in the room, and I want to start with Crystal IS. Harry, thank you so much for being with us. We discussed with you a lot about the UVC LEDs. I want to understand what has happened in the last year on this market and what kind of potential cooperations opportunities we have with a member. Harry from Crystal IS. We may have a problem with the sound of Harry.
Okay.
Harry, are you there?
Can you hear me, Jose?
Loud and clear.
Okay, thanks, Jose. I mean, it was exciting presentations today. Really enjoyed it. So where we come from in agriculture, Agriphotonics is we offer two different solutions. One is in the use of UVC LEDs for water disinfection. And this becomes important in indoor vertical farming, where you have recirculation of water. Like I think some of the presenters mentioned, the promise of indoor vertical farming is it uses less water and less fertilizers. It optimizes it. And so if you're recirculating water, so disinfection becomes a key thing. And that's something where we are starting to work with potential customers, and we are constantly looking for partners who can bring out solutions with our LEDs. So in terms of the improvements that we have made, we are continuing, just like you saw with visible LEDs, we are continuing to improve the milliwatt and reliability performance. So the dollar per milliwatt is at a level which makes it feasible for companies to start developing new solutions. So that's one aspect of it, which is optimizing or having disinfection of water. The second one is, I think we discussed in the last meeting that we had, which is we have this LED now at 235 nanometers, which you can use to detect nitrate in the soil. So that's very key. So just like you optimize water use efficiency, nitrogen use efficiency is also important. So Europe's common agricultural policy also outlines that because 70% of nitrogen is lost in agriculture. So with our LED, so traditionally you had to use UV lamps, which were not the most easy to use for small footprint applications. So with our LED now, you can develop sensors where you can measure nitrate right underneath the soil. So you can optimize the nitrogen addition. So those are the couple of things that we are interested in working with customers to develop those markets.
After the previous meeting, we did a lot of introductions to you, and you followed up with every one of them. Once again, if anybody can help crystallize in the all activities under the ground, they are helping me a little bit, because I'm super excited of what happened in 2020 and 2021, perhaps for the wrong reasons, but what happened in the UVC market. I want to go to the capital of optics in Europe and the capital of optics in the world. I want to go to Jena. I cannot wait more. We have somebody from SAIS in the room. Is that correct?
That would be me. Jose.
Guillaume Goward, thank you very much for being with us, Guillaume. This was exciting 2 hours talking about Agriphotonics. You're from SAIS. Tell us about which opportunities for cooperation have we underlined.
Right, indeed. I'm from SAIS, actually not from Jena, but so we have an innovation hub in Karlsruhe where we look at new markets, and especially in the field of Agriphotonics. In fact, SAIS is already active in the field of Agriphotonics, so has released a spectrometer, which is integrated in the farming vehicles, so with John Deere, not to name it. So this is already happening. And I am myself looking at application where not only would like to determine if a plant is healthy or not, but maybe retrieve some more finer information. For example, nutrient contents, and so on and so forth. So that could be meaning using different type of spectroscopic methods, Raman spectroscopy and other, to retrieve those type of different informations. And maybe one message to the previous speaker. So somebody talked about combining hyperspectral with X-ray detectors. ZEISS is really known for X-ray detectors. So here there might be some room for discussions. And ZEISS is also good at machine learning, image processing, image sequencing. So not only we could discuss on the hardware level, but also in terms of image processing. And I would be very happy if anyone comes in touch with me with that.
That beautiful building that you have in Karlsruhe next to, well, together with Nanoscribe. I'm such a huge fan of what you're building there, and I can't wait to start traveling again and come to visit you. Combination of infrared and hyperspectral. Let's do something together here. Do we have anybody from OpSign in the room? Daniel Plant is in the room, maybe.
Yes.
The birthday boy.
Birthday boy, Daniel Plant. We're looking to start a project with CalScience combining their infrared with their hyperspectral. Are you up for this? And what do you do actually?
Yeah, so thank you very much. This is my first introduction to EPIC, and it looks like you have a great programming and great network put together. So Opsony, we've just launched this in the last couple of weeks, and it's a venture of PSI, which is a European company called Photon Systems Instrumentation. And PSI for 25 years has been building sensors and systems really at the heart of Agriphotonics for, elucidating insights from plants. So we build everything from cell culture all the way up to the field scale. And we have a broad portfolio of sensors. We do not manufacture chips and filters. We buy those from Hamamatsu and HORIBA, etc. We build everything else ourselves. Opsony is very much focused on taking this portfolio of technology, specifically focused on hyperspectral at the moment, but always open to discussing, other technologies in our portfolio. So Opsony is really for promoting these technologies and really developing a commercial and industrial-oriented brand around our portfolio of sensors. So I'd really encourage you to check out the technical specifications of our hyperspectral sensors on the Opsony site. If there's anything more you want to learn about PSI, X-ray, thermal, phenotyping systems, UAV, multispectral, whatever, you can check out psi.zz and hyperspec.org for more technical details. And I look forward to meeting all of you, frankly. Thank you.
Daniel, as a birthday present, we are going to get you a lot of introductions, because the fact that you do not make the hardware part makes us super excited to bring you different collaborations with our sensors, with our camera. You heard from SPECIM, you heard from Nireos. There's lots of things that we can do together. Happy birthday.
Thank you, Jose.
Ciao, Luca Nardi from Enea. ¿Cómo estáis? Luca.
Hi.
Ciao, thank you so much
well.
for being with us at this meeting. Okay. I wanted you to give us a bit of closing remark because you have done a lot of innovation on this market. You heard a lot. We discussed a lot from hubs all the way to underground technologies. Really, the scope was huge. What kind of cooperations, what kind of ideas for R&D projects come to mind?
In our research center, we study agrobiotechnologies. And in particular, now we are applying on container farming and vertical farming solutions. We use LED lights, and we still are using now a SPECIM camera. We are on the way of buying a IQ camera, and we are integrating several methods like fluorescence imaging with these techniques and also thermal imaging to optimize the process of growth of plants and the development. And we are really interested in this. And also we cooperate with a lot of private companies on this. We are really interested in this argument and what you are doing now. It is important to have this collaboration, possible collaboration.
For me, it was an incredible meeting. I would like to remind a lot of people who are wondering, we do have companies like Mars or like PepsiCo in the room, but they wanted to be anonymous because of the sensitivity of the topic. They've been asking many of the questions I've been asking during the meeting, and we are going to make a lot of introductions with those. For me, this kind of meeting in 2 hours is like when you really can go through a lot of potential cooperations. We heard from SeeTree about the need for reliable, low-cost imaging. They want to explore the visible on the infrared. We heard from smartHAPS about the idea of thermal monitoring of farms from hubs. We have from Syngenta Seeds looking from fluorescent monitoring. We have from Xenix that they're interested. They make fantastic 800 to 1.7 micrometers cameras, and they're looking for potential cooperation with filter manufacturers. We heard from Crocus Labs about the need for sensors and colorimeters for light monitoring. We heard, and this was very important, from Monica Prado, we heard Generation.pt. This is a digital innovation hub on agriculture. Basically, they want to digitize agriculture, open for any photonic technology that can have another value of agriculture. And finally, we heard from my startup, MantiSpectra, about the need for a scaling up process to put their chip into volume production. That was really, really, truly epic. All I have to say is that it looks like the meeting is finished now. It's wrong. The meeting starts now. Now it is a time for the cooperations. If you attend a meeting like this and you don't really follow up, nothing happens. You have to make sure that you contact the potential partners at this meeting. If you want to get in touch with any of the participants today, send me an email, jose.pozo@epic-azo.com. I will try to keep my inbox clean. I make all the connections and I love doing that. On behalf of a fantastic team of superstars at Epic, people with technology, people with background on life sciences, on integrated photonics, on laser technologies, on optics, on quantum technologies, people who love marketing and communication, people who are fantastic event organizers, a great innovation manager, a great marketing manager, a great CFO, Carlos Lee as the CEO, and myself at the Geek of Photonics. All I want to say is, wash your hands, wear a mask. I can't wait to start traveling. See you next Monday. Green energy generation, photovoltaics, wind and hydrogen fuel cells. It's gonna be epic. Until then, see you later. Bye-bye.